So in physics, we've been studying about rotations. And now we're going to talk about torque and momentum, and angular momentum. Okay, and this torque in this case is a force in different um, positions, different directions that will make a rotation. So let me make myself clearer. Yeah, so here we have a circle. Let me draw it bigger. Okay, here we have our circle. And now what we are going to do is now I'm going to do a torque. So first we need a force going in this direction over here. Uh, Here I'm going to be doing this force, and I'm going to be doing the same force but to the other side. Okay, the same force. And so what this makes is a rotation. Say here is 10 newtons. I can do a circle, so let's say it's 11 newtons over here, and over here is also 11 newtons. 11 newtons of force. Okay, and so we will do a rotation, and we have the angular momentum. So the linear momentum is mass times velocity, right? And this velocity over here is a vector. But now this is quantity of movement. Sorry for that. It is a quantity of movement. But now what we're going to in the angular momentum, instead of being mass, it's the moment of inertia that we've already studied. And velocity is going to be the angular velocity. Or we can use acceleration, which is the torque. Torque. I don't have Greek letters, but this would be a tau. Is equal to I, which is the moment of inertia, times alpha, which is the acceleration, and alpha, and we have L, which is angular momentum, and it's given by where is it? By IW. I times W, which actually it's not W, is omega. But actually L is equal to the mass times the radius of the circle. So So stocking is mass times the radius times the angular velocity, which is v. But this here, but the angular velocity is actually equal to m times times r times times r times omega. And so we have L is equal to m times r squared times omega, and m times r squared is I, right? Actually, is the integral of mi squared gives us I, and so L is equal to I omega. Okay, I times omega. And well, that's it. L is constant. So yeah. So we know that torque is I times A. A is angular acceleration. So torque. The moment of inertia, it would be kind of like the mass. Moment of inertia is mass. So torque is equal to mass times r squared times acceleration. In this case, angular acceleration. And so uh, the difference in omega by time is acceleration. And omega is r times w, r times alpha is r times uh, omega divided by time, by t. Okay, so it would be, okay, let's do this like it's here. So let's say I have a disk with mass 1 kilogram, and the radius is 10 centimeters, so it will be 100 centimeters squared. Let's say meter, just to join SI units. Let's say like is 0.1 meters. Now let's square it. So 1/10 times 1/10 is 1/100th. So it's 0.001 meters squared. And the acceleration would be, let's say, 360 degrees radians per second squared. Okay, so then we would have 360 divided by times 1/100. Well, that is 3.6. So torque would be 3.6 what? Kilogram meter squared divided by second squared. And we don't need to put the radians, but and so what is this? This is kilogram meter over second squared times meter. Well, this we know it's Newton times meter, and Newton meter, if I'm not wrong, is joule, whatever, joule. Yeah, I checked and that's it. So it's 3.6 joules is energy, torque is energy. And so yeah, that's it.